significant need for to improve yourself. I know that driving the lowest quizzes will help, but I think really in looking at the next few exams, you really need to study and make sure you improve your background and make sure you understand new materials, so you can do a lot better. And remember, summer courses are very fast. It's very easy to fall behind. And also remember, calculus is a demanding course. You need to study many hours a week, at least 12 and possibly more. Okay. Are there any questions? Any questions? Are you okay? Is the camera okay? Or
Yes, it is.
just push, which button?
Mm-hmm,
Are you already recording this? Okay, I look so foolish at the beginning of a few minutes. That's okay.
Okay.
Nobody else will bother to watch me other than this class, so I don't mind. Okay, so we're talking about implicit differentiation the other day, and we're going to finish that. And then we are going to talk about the related rates after. So let me remind you that the example that we did previously. So this is the section 2.6 on implicit differentiation. Example, given a curve, a equation, as we knew, this represents a circle. And we want to find out the slope of tangent line, essentially dy dx, at the point x equals 3, y equals -4. Right? And the way we did is, first of all, let's try to understand the picture. Well, the picture is supposed to be prettier than that, but it's okay. This is a circle. Okay, origin, center is the origin, and the radius is equal to 5. And we're looking at the slope of tangent line at this particular point. All right. So what we did was basically we rewrite. First, you rewrite the equation x squared plus y squared equals to 25. All right. You do this all the time. I mean, this is always your step 1. And then you take a dx on both sides. And this is always your next step. Okay. What are you going to get? Well, you're going to get a 2x. That is the derivative of x squared. And what are you going to get from here? 2y. Now, is it just the 2y?
Times y prime.
You have the times y prime. Why is that? Because we're taking derivative with respect to x. You really should think about y as a function of x. Therefore, y is really a yx. So this y squared is really just yx squared. And you apply the generalized power rule, which will give you 2y times y prime. Okay? So don't forget the y prime here. And the right-hand side is equal to 0. And from there, you can solve for y prime. Y prime is just equal to cancel out the 2, move x to the other side, and divide by y. You will get negative x over y. Right? Questions? And eventually, you substitute x equals 3, y equals -4, and you get your final answer. So the final answer is just equal to 3 or 4. All right, let's look at how related race curve how it works to the related race problem. So I'm going to jump to section 2.8 for now. And we'll come back with a few exercises in a moment. Now let's look at the example, next example, so 2.8, related rates. Okay. I'm not sure if the camera is still facing this part, but maybe it's okay.
Mm-hmm.
So example, let's consider a particle moving on a curve, this curve, which is given by the equation x squared plus y squared equals to 25. Now you probably recognize that this is the same equation as what we had before. Yes, it is the same equation. Therefore, the particle moves on a circle. Suppose that at a particular moment, at time, let's say, t equals to 10, it really doesn't matter what t is. So at some particular moment, suppose that x equals to 3, y equals to minus 4, and suppose that dx dt is equal to 6. The question is to find out dy dt at this particular moment. Okay. Let me make sure you make it clear. At t equals to 10, it means at that particular moment, t equals to 10. So you can think about this as a kind of physics problem where you have a curve, which is a circle here. Right? Same circle as before. And at a particular moment, when t equals to 10, the particle is at this point, which is x equals 3, y equals -4. Okay? So the particle is moving on this circle here. And what does this say? Dx dt equals 6. That means when the particle is moving, if you look at the x component, or in other words, you project this particle onto the x-axis. This is the x-axis. This is the y-axis. The x component, the shadow of the particle on the x-axis moves at this rate. Okay. By the way, based on that data, can you tell me at that moment, is the particle moving clockwise or counterclockwise? Can you tell that? Based on what I have over here. It's counterclockwise, is it? Why is it counterclockwise? Yeah, because if you look at the projection onto the x-axis, as you can see, dx dt equals 6. That means the shadow is moving this way, to the right. And the only way for that to happen is that the particle has to move this way. Has to move counterclockwise in order for that to happen, right? Is that clear to us? So the particle on a circle, it moves either this way or the other way. Counterclockwise or clockwise. If it moves clockwise, then you look at the shadow on the x-axis. Obviously, it will move this way. That's opposite from what we're given. So it has to move counterclockwise, and that shows the x dt is positive. Right? It doesn't matter anyway. It's a useful thing to know. It really doesn't matter as far as for the answer you're going to get. So how do we do this? Well, just like the idea of implicit differentiation, we can apply the same idea over here, except here, x will be a function of t, and y will be a function of t as well. Okay? So previously, we had x is just x, y is yx. And now you can think about x. I thought this is the green, but I was fooled. It's a black thing with a green clothes on. Okay. Try it again. So x, you should now think about x as a function of t. And y is also a function of t. So I'm trying to write a solution here, and so you can compare. So this is our new solution. So before we took d dx, and now we're going to take, instead of this, we're going to take, should I just cross this out and do d dt? Okay. So we're going to take a d dt on both sides. And keep in mind that x is a function of t. When you take a d dt, what are you going to get from x squared? Are you going to get just a 2x as before? No.
X prime.
You're going to get a 2x x prime. Yeah? That's because x is a function of t. And x prime is really what? dx d what? dt. Right? So it's really a 2x dx dt. So we're going to have, I guess I try to write this over here. So instead of that, we're going to have 2x dx dt, which is your x prime. All right? What will happen with your y squared then? You're going to have 2y dy dt, which you can write y prime. Either way, you can write dy dt or you can write y prime. So 2y y prime equals to what? 0, because 25 divided is 0, so that part is okay. And then we just put all the data into here. X equals 3, dx dt is 6, y is -4, and you want to look for y prime. Right? The rest is all simple. Cancel out the 2 on both sides. You substitute x equals 3. Okay, you substitute the dx dt equals 6, so 3 times 6. You substitute y equals -4, so -4, and you look for y prime. And you solve for y prime is just equal to 18 over 4, right? Which equals to 9 over 2. Yeah. Let me just write 9 over 2. Question?
So the time t equals 10 doesn't really...
It doesn't matter. It's just at a particular moment. Yeah. If I change the problem to something like, if you want t to be relevant, if I change the problem to something like 3 t to the 4th power times x squared plus y squared equals 25, and do this, then t equals 10 would be relevant. Because when you take a dt and you're going to have a t here, and you have to substitute t equals 10. But for the original problem, it doesn't matter. We're going to do some exercises. So let me write the problem here, and then I'll give you a few minutes to do the exercise. I have 2 problems here. This is really an exercise of 2.6. y. Suppose we have this equation. And when you find out dy dx, you can work this by yourself, and then maybe one of you can show your work here. Let's do another exercise.